Rana Plaza, a building with a basement, a ground floor, and 7 floors on top, collapsed on April 24th, 2013 in Bangladesh. It was a tragedy that shocked the world, but when we look closer, it becomes clear. This collapse didn't come out of nowhere. The building had illegal extra floors, added without recalculating the original structure. And here's the real question. Would it have survived even without those extra floors? Originally, it was designed as an office building, but it became a garment factory with machines, heavy loads, and vibration. Far beyond what the structure was meant to carry, let's start with the entire building. The full structure is modeled, and the reinforcement in the columns is included, so we can immediately see the outcome. Now here's the critical part. The first columns to fail in the real collapse were located in the basement. So that's where we focus. Here you see the complete building on screen. We're not using any safety factors now. We're checking the column up to the second floor. There's no need to go higher. The upper levels are no longer decisive for failure. Now let's focus on the basement. Immediately, we see red zones appearing. That means that the unity check exceeds 1.0, even without safety factors. These are the critical areas, the exact spots where the building was already overloaded before it ever collapsed. Now let's remove the 2 illegal top floors, the ones that were never approved by any permit. And what do we see? Suddenly, no more red zones. Everything turns green. At first glance, that looks like a green light, but here's the problem. The unity check is exactly 1.0. That means there is no reserve, a bit more weight, or if the concrete was poorly cast, this building could still collapse. So let's take it one step further. We now remove one more floor, a floor that actually had a permit, but for which no structural drawings or calculations were ever submitted. Now, with safety factors as required by structural regulations. And what happens? The columns exceed the unity check again. We're back in the red. This tells us if the building had been assessed by code, one more floor would have to be removed to stay within allowable limits. But here's the nuance. Although the UC is over 1.0, this level of exceedance doesn't necessarily mean collapse. Now one more floor has been removed, and everything is green. That means the structure fully complies. But here's the shocking part. Even one floor that was submitted with drawings and calculations was already too much for this type of use. If the building had been used as office space, that extra floor might have been acceptable. But with industrial use, it was structurally overloaded from the start. We also see a high foundation reaction of about 3,300 kilonewtons. In most cases, this would require a pile foundation, but in Rana Plaza, such piles were most likely not present. Now let's take it one step deeper. Let's check the stress distribution inside the structure. 12 megapascals is already quite high for low-quality concrete, but with the help of reinforcement, these columns can still reach that stress level. On screen, we clearly see which columns are under the most compression. In this model, referring to the color scale, dark blue indicates the highest compressive stress currently present. These are the columns that support the largest floor areas and therefore carry the heaviest loads in the structure. Knowing that 12 megapascals was the maximum compressive stress that could safely be handled, we can now clearly see how the actual stress is nearly doubled that limit. With this kind of low-quality concrete, such an increase most likely caused the columns to fail, either through crushing or splitting. The most concerning failure mechanism is clearly visible in the image where we see vertical cracks and crushed concrete, just like what happened in Rana Plaza. And we know this wasn't invisible. The municipality had closed the building because the cracks were already too severe. But still, some companies, especially in the garment sector, forced workers to return to the building the next morning. So, in conclusion, the 3 top floors were simply too much for the columns to carry. And beyond that, to fully comply with safety standards and regulations, it would have been better not to build the 4th floor either, knowing that the concrete quality was no more than C1620. See the table for the column and reinforcement dimensions. you might notice the column sizes actually seem suitable for a taller structure. And the reinforcement wasn't bad either, I'm convinced. With just one less illegal floor, lighter industrial use, and a significantly better concrete mix, this collapse would never have happened. But then again, the foundation may have failed eventually anyway. Thanks for watching, and subscribe for more deep dives into structural failures around the world.